Okay, good morning once again. Today we're going to continue our discussion on multiple linear regression. Just a quick review. We said that there are several assumptions that are made as far as the use of multiple linear regression, OLS, ordinary least squares, is concerned. We looked at those assumptions. And we said that it's not enough for us just to generate the final model. We have to check if our model is consistent with the assumptions of the classical linear regression model. So we were looking at the wage data set. The wage data set has 8 variables, where we were trying to predict or explain hourly wage based on 7 other explanatory variables, where 3 of them were categorical variables and 4 are quantitative variables. So what we did was to one of the things that we did was to convert our categorical variables into factors, right? If you recall that, guys. So in R, that's very easy to do. Just close some of the outputs that we have. So, okay, so here, okay, we use this as that factor, as that factor wage. So let me just run this, maybe just to be sure. To convert the categorical variable into a factor. And as we said, guys, not all categorical variables can be converted into factor. It has to make sense. It has to be, it means that it can be used as a classifier. Okay, if we check the structure of wage, we can now see that the race, gender, and civil status are now factors. And we said that R uses the convention where the level, for example, for race, white and non-white, the one that comes first alphabetically is the one that is given the value of 0, which means that it's the benchmark or the reference variable, reference value. Okay, so we can check that, guys. We can check that. Let's see. Okay. All right, here. Let's add here a code chunk. Okay, there's a function. This is what I forgot last time. No? Okay, we can use the contrasts. This is from base R. Contrasts function. And let's see, yung wage natin, that's your race. We already made this as a factor, yung race. Let's see, contrasts, guys. Diyan na ba siya? Tagal mag-run something. Oops, error. Okay. Yeah, here. All right. So nag-run ba sa inyo, guys? Let me run that again. Yeah. Okay. So here we can see that the contrast function, guys, will define for us ano yung reference variable. So here, non-white is 0, white is 1. Okay. If we check the others, lagyan natin contrasts, wage, and then sa gender, contrasts. Check, guys, kung tama yung assumption natin. Zero. Status. Okay. So let's run this together. Contrasts. Okay. So we have here, guys, sabi natin, di ba, yung sa gender, yung female ang ginawa niyang 0, dun sa civil status, yung merit ang ginawa niyang 0. Diba? Those were the reference variables. If you have 3 or 4 or more than 2 levels, then it will also tell us ano yung ginawa niyang 0. Okay, there was one, I think somebody chatted me, asking me if it's possible to change the benchmark. Pwede, guys, pwede. Okay, for example, you don't want the benchmark to be non-white. Gusto mo ang benchmark yung white. Okay, so how can we do that? So here, to change benchmark for a factor. How do you do that, guys? Kasi di ba ang default dito, kunyari sa race, ang default, guys, is si non-white yung benchmark. If I want this to become white, then pwede kong gawin na let's create this variable wage. Okay, pareho pa rin, wage, and then si race, no? Wage race, okay, out minus. So what I'm going to do is we can use the re-level function of it. Re-level, babaguhin yung level. Diba yung mga levels natin, ito yung mga different classifiers natin dun sa factor natin, diba? Re-level, wage, re-level natin si wage, raise pa rin. Okay, and then comma. Ang reference natin ngayon will be equal to, kasi kanina ang reference natin si non-white, diba? And here, I'm changing the benchmark, the reference from non-white into white. Okay, so run natin to. Okay, and then check natin si contrast ulit. Contrast ni race. Let's see what happened. Run. Okay, tingnan nyo, guys. Ang naging benchmark na si white. Okay, so what will now appear in our regression output is the non-white. Okay. Any questions so far, guys? So when you're dealing with factors, guys, you can check whatever is the reference variable. Alam natin na ang reference variable will be the level that arises first alphabetically. Okay, but we can change the reference by using the re-level function. Ilalagay natin po ang reference. Okay, so babalik ko na lang siya sa non-white para level ko siya, and then kinontrast ko ulit. Okay, so balik na sa non-white yung reference. Okay, pause muna ako. Any questions, guys, so far? Okay, we were not able to discuss this last time. Okay? Dali lang guys ha, isang minute. Okay, so sorry about that class. Okay, so okay na guys, yung ano, yung pag-identify ng benchmark, pag-change ng benchmark, kindly chat please guys kung clear siya sa atin. Okay, good, good. So now you know guys na pwedeng baguhin yung benchmark. And then of course, pag interpret natin yan, whatever the benchmark is, sa output, hindi siya lalabas. No? Kaya nga yung nag-regression tayo dati, ang lumalabas kunyari, race na white. Bakit race white ang output natin? Ang regression output? Kasi sinan-white yung benchmark. And then when we interpret the parameter, the coefficient, it has to be always interpreted in relation to your benchmark, which is the variable that does not appear there, no? Yung ginawang zero. Okay, so far guys, we have run to multiple linear regression natin, and we said that when we run a particular model, itong model 2 for example, ginawa natin lahat ng mga variables sinama natin. No? So si hourly wage regressed on all the variables, quantitative at saka yung factor variables. Okay, and then when we run that, let me just run this one. When we run this, this will create an object. In this case, we named it model 2. And this model 2 is a list. It consists of several objects, a list of 13. Then yung summary niya, okay. So here is our output, no? Education, experience, etc. And then we have here the factors, race, white. So when you interpret this, we said that white people tend to receive 10 centavos or 11 centavos more hourly wage compared to their non-white counterparts, ceteris paribus. Just so happen that this is insignificant. Ganun din kay gender male at saka kay single. Okay, what's the meaning of this one, guys? What's the meaning of negative 3.38, negative 3.39? Can anyone explain what's the meaning of that? I don't think we were able to clearly explain that last time. Anyone? Ano ibig sabihin ng negative 3.39?
Sir, is it if zero yung education, zero then yung experience, like all the variables are zero,
Yes, correct.
yan, the person earns negative $3.38.
Yes, okay. So that's the average hourly wage of a person who is what? That does not have any, that has 0 years of education, 0 years of experience, 0 years of tenure, who is non-white, who is female, and who is married. Diba? And who has no dependents. All right? So take note, guys. I said walang education, 0 years of education, 0 years of experience, 0 years of tenure, who is non-white, female, married person, and with no dependents. Okay, that's what we mean by negative 3.38. Of course, that does not have any practical or physical interpretation or meaning kasi wala namang hourly wage na negative, no? Diba? Pero yung interpretation, guys, who is white, okay, female, married. Diba? Bakit? Kasi sabi natin, pag yung intercept, it's the value, average value of your dependent variable when all your predictors are zero. So, isi-zero out natin lahat to. Yung race white is equal to 0, that means female yan, di ba? Benchmark yung female is equal to 0 yan, di ba? Ganon din sa gender, guys. So, non-white pala to sa race, female sa gender, at saka married sa civil status. And then who has no dependent, no dependents. So that's what we mean by this intercept. So be careful, guys, when you interpret, no? Lalo po may mga factors, medyo becomes a bit tricky. No? It becomes a bit tricky. So, kunyari, guys, let's do this. Ano ngayon yung average na hourly wage na isang tao na may 1 year of education, 1 year of experience, tenure, who is white, who is female, and who is married, and has 1 number of dependents. How do we now compute for the estimated or average hourly wage? Ang gagawin natin, guys, so negative 3.38, no? Okay, tapos plus itong 0.57 kasi 1 year of education. Tapos plus 0.02 kasi 1 year of experience. So times 1 yan. Tenure, isang year daw ng tenure, so plus 0.38. Tapos white daw siya, so plus 0.11. Tapos female, so hindi papasok to sa equation. Diba? Kasi pag female, 0 yan. Diba? So this will not enter the equation. Tapos single, so minus 0.454, minus 0.46 pa. Tapos 1 dependent plus 0.14. Okay? So do you get that, guys? Nakuha ba? Mode 1, mode 2 na to. So ito, no? Alright, so negative 3.38. So sabi natin 1 year of education. So idadagdag natin yun. No? Plus 0.57. 1 year of experience, so plus 0.02. 1 year of tenure, 0.13, 0.14. And then who is white? So add pa rin natin to kasi pumasok si white. No? Who is female? So si female, guys, 0 siya. So hindi natin ipapasok ng 1.75. Okay, and then who is Ano ba example natin? Single, si single, ima-minus natin itong 0.46 and who has one dependent, so plus 0.146. Alright? Is that clear, guys? Okay, we'll have more examples of that, but I'm just discussing with you how to interpret or how to compute for the average hourly wage of a person with the following attributes. Okay, 1 year of education, etc. Siyempre, pag 10 years of education, times 10 to. Okay, is that clear, guys? Paki-chat naman please kung clear. Would you want me to repeat that or klaro naman so far? Don't worry, guys. We'll have more examples of that. No? We'll have more examples of that. We'll go to that when we discuss more in greater detail itong mga factors na to. Okay, good. Thank you so much for your feedback. All right. So, sabi natin, guys, when we generate the model, and there will be some who are not significant, okay, and then we just do not identify our final model by deleting all the insignificant predictors. Hindi ganun. We follow what we call the stepwise regression. So stepwise regression, we remove, particularly backward, we remove the insignificant variables one at a time by choosing the lowest p-value. Kasi sabi natin, that has the lowest predictive power. Absolute value, guys. Absolute value. So dito, tinanggal natin tinanggal natin dito? Number of dependents. No? So one at a time, tinanggal natin siya, di ba? Okay, I hope you still recall that. Okay, until we have a model where all are significant. And we compare between models. Yung sinasabi natin, ano ba yung basis natin? Either the adjusted R-squared, AIC, AKIK, or the p-value, yung based on the ANOVA. Okay? And usually, ang ginagamit yung p-value. Kasi minsan, nagkaka-conflict sila. Minsan, mas mataas yung adjusted R-squared, pero mas mababa yung AKIK. Tapos hindi significant. So, anong gagamitin? So, just to be safe, yung standard na ginagamit natin is the p-value. Okay? And then we generate yung model number 5, di ba? Ito yung model number 5 natin. Okay, model number 5 natin is this one, no? Where we, ang natitira na lang variables natin are, okay, si education, si tenure, si gender, at saka si civil status. Those were the only remaining variables that we used, and all of them were significant. So ito na yung final model natin. And we even checked whether this is better than the unrestricted model number 4, the one that had more predictors. And lumabas dito na mas maganda si restricted model, no? Si model number 5. Okay, ito by virtue of the insignificant p. Kasi sabi natin ang null hypothesis nito, the restricted model, the one which has the lesser predictors, in this case model number 5, is preferred to the unrestricted, and p-value is 0.11, so we fail to reject the null hypothesis. So mas maganda nga talaga si model number 5. Okay. All right. Okay, now we're going to go back to this, guys. So babalikan natin itong mga residual analysis na ito. Pero ngayon, ang gagawin muna natin, puntahan muna natin, guys, si stepwise regression. Kasi what we did was actually a stepwise regression. And here, the OLS-RR package comes in very, very handy. So we already installed OLS last time. I-library na lang natin para ma-access natin yung mga guys, yung mga functionalities ng OLS-RR. All right. So here, okay, we're going to create an object called model. Ito actually model number 2 natin kanina, no? Pero let's just have a different name for that. model is linear linear model ng hourly wage regress on all your variables. No? Data is equal to wage. Okay, and then we're going to ask R using the OLSRR package to do a stepwise regression. Okay, ano ba yung stepwise regression, guys? Ang stepwise regression, dalawang klase. Actually, tatlo. No? Merong backward na stepwise regression, merong forward na stepwise regression, at saka meron yung mixed, no? Mixed na stepwise regression. Pwedeng combination ng backward at saka ng forward. Ano yung difference nila? What we did last time was the backward stepwise regression. Sa backward stepwise regression, you first include all your predictors. Pinapasok muna natin sila, and then one by one, tinatanggal natin yung mga hindi significant, which is what we did last time, diba? That was actually a stepwise regression. Okay, so pero manual tayo, no? Inisa-isa natin. With the OLSRR package, bibigay sa ating result automatically na, no? Hindi na natin i-manual yung ano natin, yung regression natin, yung backward. Ano naman yung forward? Yung forward naman, guys, it will start with zero muna, zero variable. So pwede bang ano na lang, average na lang ng dependent variable ang kukunin? Okay? So ang gagawin niya, i-compare niya, paano kung ang ipapasok ko muna si variable 1, 2, 3, 4, 5, 6, kung ilan man ang predictors. Hahanapin niya doon kung sino yung pinakamaganda. Kung iisa lang yung predictor. Okay? So yun ang idadagdag niya muna. Tapos pangalawa, second step, magdadagdag na naman siya ng isa. Okay? Hahanapin niya yung combination, the first variable and the second one, sino yung among the remaining variables, sino yung mas maganda. Ganun guys yung forward regression. Okay? Mas mahirap siya gawin manually, no? Kasi hahanapin mo guys kung sino yung pinakamagandang ipapasok mo among all the variables. Ibig sabihin, iisa-isahin mo yun. Iisa-isahin mo yun. So that's quite difficult. So backward stepwise regression is easier to do sa manual. Kaya nga hindi tayo forward stepwise regression kasi that will really be very difficult to do manually. Okay. So here, ang gagawin natin muna dito, magfo-forward muna tayo. Forward na stepwise regression. Now, dalawang klaseng methods, guys, pag nagfo-forward o backward in terms of OLSRR. Okay, number one is using p-value. Number two is using AIC. So, ang basis natin pwedeng yung p-value or pwedeng AIC yung basis natin. Okay, here, we're starting first with ito yung function. OLS step forward P. Itong P na to guys, ibig sabihin nito, ang gagamitin natin, P-value in order to determine kung sino yung susunod na variable na ipapasok. And then here, you have the parameter. Di ba, ang gagamitin natin model is this one, model, which is this one. And then P-enter, note it's P-enter. Meron namang P-RM, P-remove, no? Backward naman yun. Pag P-enter, is equal to 0.05. So papasok lang yung variable na yun kung yung p-value niya, kung pumasok siya, is less than 0.05. Yung level of significance natin. Okay. So, run natin to guys. Let's run this. Okay, library, then i-ano natin. We're calling this object forward fit.p. No? Para forward stepwise regression, and then P using P method. Okay, let's run this. Hindi ko na i-run si library. Tinarun ko na muna. Control Enter. Okay. So, nag-generate na siya ng object na forward fit. So, no? So, we now have this object forward fit.p. Okay. So now, and it's a list, guys. It's a list of 11 items. So let's ask R to print this. Ano ba laman itong forward fit.p na to? Let's run this. Oops. May output na ako dito guys kasi I use this in another class. I-X ko na muna ito. Alright. Forward fit.p, let's see. So ano yung laman ng object na to? Ano problema yung R ko? Hindi pa pala tapos. Okay. May ano ako dito. Run ko ulit to. Okay, nag-run ko siya. Okay. Yan guys. Nilagyan ko ng parenthesis, di ba? It already generated the parang summary of the object. Okay, here. So this is the result of that forward forward stepwise regression, selection summary. So step 1, una niyang pinasok si education, a variable entered. And then may mga metrics siya, no? R squared, adjusted R squared. Okay, this is Marlow's measure. Okay. Ito ang measurement ko ng the lower the better to. Explain na lang natin ulit as we go along. And then AIC, and then yung root mean square error. So these measures, guys, CP, AIC are root mean squares around C, guys. These are the lower the better. Ito naman si R squared, adjusted R squared, the higher the better. Okay, so based on p-value, si education na pinasok niya. Second, ang pinasok niya, second step, guys, pinasok niya sa tenure. Notice that the R squared increased, adjusted R squared increased. Si CP, guys, bumaba. Akaiki, bumaba. Ramsey, guys, bumaba. Yung root mean square error. Okay, and then the third, gender, and then civil status. So you notice, guys, yung mga R squared natin, adjusted R squared, tumaas. Si CP, Akaiki, at saka si Ramsey, bumaba. And notice, guys, these are the variables that we generated yung final model natin, yung model 5. So nagkapareho lang siya dito sa forward stepwise regression using p-value. Okay? Now, if you want, guys, if you want to plot everything, lahat ng details, ito yun. Okay, so here I'm creating this forward fit 1, kanina forward fit lang. So pareho lang siya, ilalagay lang natin dito details is equal to true. So ito guys, ibibigay yung detalye kung paano niya pinasok yung mga variable. So let's run this. Lalagay lang ako ng content space dito. So medyo comprehensive yung result na ito. So details is equal to true. Let's run this. Okay, and then it will give you really a detailed account of what happened to your forward stepwise regression. Tingnan natin, ha? Okay. So, comprehensive guys yung ano, no? Yung result. Ito na. Details is equal to 2. So, let's go down. Ayan. First, guys, forward selection, no? So, ito yung mga candidate terms natin. Ito yung mga candidate variables natin. Kasi pito siya. So, selecting. Number 1, sino yung unang sinelect niya? Unang sinelect niya is, di ba? 1. Step 1 plus education. Okay? So, nung dinagdag niya sa education, ito nangyari. Okay? So, this is better than na walang predictor. Kunyari, si hourly wage, just get the average. Yun na yung ano natin. Yun na yung predicted value natin. But when we added si education, okay, which is the first variable na pinasok niya, Okay? So what happened? So may mga ano dito, no? May mga metrics na pinapakita. Okay? Andiyan yung model summary, uh, andiyan yung adjust R squared, andiyan yung correlation, adjusted R squared, okay? Yung predicted na R squared. Okay? And may mga ano, yung Ramsey, root mean square error, and then meron yung mean square error, and then mean absolute error. Okay? Kasi minsan guys, yung iba, ginagamit na basis to. Okay, then, nag-ANOVA siya, no? May ANOVA dito. Significant siya. Ibig sabihin, beta null is equal to beta 1 is equal to 0. We check that. And then, andito na yung individual t-test. No? T-test, and it's significant. And take note, yung confidence interval niya, hindi tumatama sa 0, kaya siya significant. While the intercept, guys, between negative 2.25 to 0.44, so ibig sabihin, possible na tumama sa 0 to, dadaanan sa 0, kaya nga hindi siya significant sa intercept. Pero, sabi nga natin guys, hindi siya significant 0.18. Pinapasok pa rin natin yung intercept kahit na hindi siya significant sa pag-estimate ng model natin. Okay, next, step number 2, tenure. Okay, so ito na naman. You notice guys, na tumaas yung adjusted R squared, bumaba yung Ramsey, bumaba yung mean square error, bumaba yung mean absolute error, etc. So significant pa rin in terms of ANOVA. Beta null is equal to beta 1 is equal to beta 2. Dalawa na kasi yung variable natin. Okay? So tapos ito naman, parameter estimates, okay, significance, education, at saka si tenure. So notice yung mga pinapasok niya guys, yung pinasok niya sa tenure, significant yan at 0.05 kasi P enter natin is equal to 0.05. Hindi siya pwede magpasok ng isang variable na yung p-value is greater than 0.05. Okay, so ganito yung guys yung forward. No? Step 3. Okay, plus gender. Pinasok na si gender. Okay, and then same thing guys. Tinanong natin individual t-test and significant. Yes, definitely significant. Okay, ito yung parameter, yung value ng parameter. Tapos and so on and so forth. Papasok siya sa number 4, pinasok niya sa civil status. Okay, if you compare guys, bumagsak yung Ramsey niyan, MSE, etc. Okay, tapos ANOVA, okay? Okay, ANOVA natin, overall goodness of fit. You can say that the model overall is able to predict our dependent variable and individual, ano natin? Individual, okay? T, okay, asa na yung significant natin? Yan, lahat. Significant. Pati si intercept na naging significant. Okay? And then what happens? Step 5, no more variables to be added. Hindi na siya magpapasok ng variable. Kasi pag nagpasok pa siya, yung p-value nun magiging less than or greater than 0.05. So, ang variables entered natin, number 1, education, number 2, tenure, number 3, gender, number 4, civil status. This is now forward stepwise regression. Okay? And then once again, the summary ng ng model natin, ANOVA, and your individual t-test. Lahat siya significant. And then ito yung mga parameters niya. Okay? Selection summary, sinummarize niya. Yung step 1, education lang. Okay, Akaiki, 277. Tapos, yung fourth step, yung final step, yung civil status, Akaiki, 2639, lower than the first one, second one, third one. Okay? And then the adjusted R squared, tumaas, 36.04. Now, pag nagdagdag pa tayo, guys, nagdagdag pa tayo ng isa, tataas yung adjusted R squared natin. Kaso, hindi siya significant. That's why, hindi niya pinasok. No? Kasi ang ano natin, ang basis natin yung p-value. Okay, the second one, guys, is forward regression using yung AIC, yung Akaiki. Alright? So, ito naman, ang basis is AIC. So, ganun din, iba lang guys yung code natin. So dito, sarado ko na to ha. Okay, here, method 1.2. Forward regression pa rin, but this time using AIC. Okay, dito nag-create tayo ng forward.fit AIC. Of course guys, ando lang to ha. You can name it any way you want. OLS, step forward. Ang kaiba nito, AIC na siya, hindi P. So then, and then model. Okay, so let's see. Ipiprint na naman niya to, no? Kasi may parenthesis tayo dito. Alright, summary dito. Okay, take a look at this. Anong kaibahan dun sa AIC method at saka sa P method? Notice guys, sa AIC method, 5 yung variables na pinasok. 5, no? Kasi, for as long as pwedeng bumaba yung AIC, ilalagay niyan. Okay, from 2077, naging 2638. Kanina 2639 lang, no? Mas mababa kung isasama sa experience. Okay? Adjusted R squared, mas tumaas, no? Mas tumaas. Alright? So, now tingnan natin guys, ha? Pwede natin i-plot yung forward fit natin ng AIC, and this will plot to us the levels ng AIC. No? Okay, take a look at this guys. So here you have education, tenure, gender, civil status, experience. As you introduce these variables, yung AIC bumababa. Okay, so pang 5 variable pinasok sa experience. And that's the minimum lowest AIC. Pag dinagdagan pa natin ng isa, tataas ng AIC nun. So that's why it's stopped at experience. So medyo may conflict guys. May conflict yung method kanina, yung p-value ginamit, tsaka AIC. That happens. That could happen. So we just have to decide kung ano. Usually ang ginagamit talaga yung p-value. Okay, but if it so happens that okay lang na ano, especially kung depende dun sa ano, no? Sa P na experience, kasi pwede yung P niya, ano P, let's say, 0.07. And then if we use, let's say, a significance level of 10%, okay pa rin naman yun. But if we strictly use the 5% significance level, then hindi siya papasok. Okay, so just be aware guys na pwede magka-conflict si AIC at saka si P-value. So nothing surprising about that. But for our purposes guys, ang gagamitin natin si P. Okay, ganun din guys ito. Okay, details is equal to true natin. So if you run that, okay, you'll have this. Okay, so forward selection method ulit. Okay, ang una guys, no? Una, step 0 niya is hourly wage based on tilde 1, ibig sabihin, it's just regressing on itself. So, ibig sabihin, average lang siya. Ibig sabihin, hindi siya gumamit ng regressor. Hindi siya gumamit ng predictor variable. So, ang AIC niya is 2870. Now, ano yung mga candidates? Tingnan natin dito, no? Ano yung mga candidates? Pag ipasok natin sa education, AIC will become 277. Compared to right now, kung wala tayong gagamitin na predictor, just get the average and compute for the AIC, 2870 siya. Pag ang gagamitin naman natin na si race, 2871, mas mataas pa kaysa dun sa ano, sa wala tayong gagamitin na predictor. So among all these guys, based on AIC, si education yung pinakamaganda. Okay? Siya yung pinakamaliit na AIC. Kasi AIC method nga to, di ba? Right. So what happens is that plus education. So ang nangyari, sa step 1 natin, kasama na si education as a predictor, AIC from 2780 naging 2777 na. Okay? Ang ano natin, model natin, hourly wage, regression, education. Okay, so next, ano yung mga candidates? Ito. Kung ipasok natin si tenure, bababa 2685. Pag ipasok natin sa race, 2779, mas mataas pa kaysa dun sa current natin na 2777. So definitely guys, itong dalawang to, hindi ipapasok kasi mas mataas pa nga yung AIC niya pagkasama yung either one of this. Kaso among those, among the others guys, ang pinakamaganda si Tenyon kasi sa yung pinakamaliit na AIC na na ma-generate, no? So plus Tenyon. So forward guys, forward stepwise regression. Sorry, just a minute. Okay, so what happened guys nung pinasok si Tenur? Sabi, yung ano natin, yung AIC magiging 2685 na lang. Bumaba. Okay? Yan na nga, naging 2685 na. Model natin, education plus Tenur. Okay, and this is really this is really self-explanatory. So, mag-add lang siya, mag-add. Okay, hanggang bumaba yung AIC. So yung step 5 niya, apat na to, no? Apat na siya guys, no? 2638 na. Pag in-add natin si number of dependents, magiging 2638 point sorry. Should be the one, lima na pala yan. Let's backtrack to step 4. Step 3. Step 4. 2639 yung ano natin, AIC. Apat yung regressors natin. Okay, so tingnan natin. may variable ba dito na pag dinagdag natin, bababa pa yung AIC? Yes guys, 2639 down to 2638. So bumaba yung AIC. Okay? Kaya ipapasok natin si experience. Kasi ang basis natin AIC guys. Now take a look at this. Sa step 5, wala na. 2638.6 tayo. Pag dinagdag pa natin si number of dependents, 2638.8 na yan. Mas mataas na yan. Kaya no more variables added. Variables entered. Yung limang yan. Final module natin. Okay, tingnan natin yung individual t-test. Okay. Lahat significant. Si civil status nga guys, significant. Barely significant na siya at 0.05. Si experience guys, kahit na pinasok pa rin natin siya kasi bumaba yung AIC. Pero hindi siya significant, not even at 10%. Okay? Diba? So yun ang yan ang parang what's the term for that? Forget the term. Anyway, yan ang nangyari guys. Kahit hindi significant sa experience, we still entered it into our model by virtue of the AIC. And this kaya nga it runs contrary with the p-value method. Sometimes naman guys, pareho lang sila. But there are times like this, no, na magkaiba sila. Okay, so from a statistical perspective, mas maganda yung p-value. Okay, so you can see here guys, yung summary, pababa talaga yung bumaba yung AIC. Okay, any questions so far guys to sa forward stepwise regression natin using p-values and using AIC? Paki-chat naman please kung clear. Isa pa lang to chat. How about the rest guys? Okay, thank you. Okay, good. Salamat. Walang questions, guys? Okay. Now we go now to the other method. Kanina forward kasi. You can also do backward. Ganun din to, dalawa. Backward using P and backward using AIC. Okay, you'll see guys that dito sa P value, ito yung eksaktong ginawa natin kanina. Okay, so ganito din function natin. Okay. So we have OLS step backward ngayon and then P. Okay? Simple lang naman yung function. No? OLS step forward or backward and then P or AIC. Okay? And then ano yung pinapa-backward natin? And then P remaining. Kanina P enter, di ba? Kasi backward na to eh. So di ba remember guys, yung backward, i-load niya muna lahat tapos isa-isa niya tatanggalin. Okay, so let's just run this lang yung details kasi equal to true, diretso na tayo. Okay, if you run this guys, you'll have this. Okay, so paki-run please and then you'll generate this. Okay, backward elimination method. So it's telling us that everything is already included in the model and then we are eliminating variables based on p-value. Okay, ito yung ginawa natin kanina guys. No? Reload natin lahat yung variables and then we looked at the p-value which is of course related to your t-stat. Okay, yung pinakamataas na p-value, generally yun yung pinakamababang t-stat absolute value. Okay, so dito, sabi dito, tatanggalin si race. So that will be your backward step 1. Variable removed. Variable race removed. Okay, so nung tinanggal natin si race, ano nangyari? Okay, ito. Naging ano na lang siya. Kanina din guys, di ba, race ang unang tinanggal natin. So pareho lang to guys, exactly the same. Education, experience, tenure, gender, civil status, number of dependents. So lahat sila guys, parehong tinanggal na yung tinanggal na yung race. And then if you're going to look at guys, yung ginawa natin kanina based on absolute value t, si number of dependents ang pinakamaliit, di ba? Right? So yan ang tatanggalan niya, no? X number of dependents. So what we were exactly doing with the manual, yun din itong backward stepwise regression. Only that guys, automatic na siya. Okay? In fact, yung details pa ng isa-isa. Okay, so tinanggal daw si number of dependents. So ang natira na lang yung 5. Education, experience, tenure, gender, and civil status. Once again, you take a look at the p-value guys, the t-stat or the p-value. Okay, ito yung t-stat niya. So ang insignificant, itong si experience at saka itong si civil status. Ang pinakamaliit absolute value na t-stat, okay, which is the same as the highest na p-value is experience. So yan ang tatanggalin. Yan, X experience, which is again exactly what we did a while ago. And then ganun na naman yan. Hahanapin na naman yung individual t-test. Meron pa bang insignificant? Okay. Wala na. Wala na. Lahat significant na. Kasi remember guys, ang basis natin dito, P remove kung 0.05 or more. Okay? So, sabi niya dito, no more variables to be removed. No more variable satisfy the condition of p-value greater than 0.05. So sinamarize siya, tinanggal si race, number of dependents, si experience. So they generate yung final model, ANOVA, okay, and then the individual t-test, significant pa sila lahat. These are your parameters, which are the same as what we had a while ago. Okay, and then sinamarize siya yung variables na tinanggal. Okay, tingnan nyo guys, no? Ito, if you take a look at this, number of dependents na AIC 2638 sa yung dalawa lang. Nung tinanggal yung pangatlo, yung AIC tumaas. So di ba it runs in conflict with the standard rule that the lower the AIC, the better. But not in this case. Not in this case. Kasi pag pinasok natin sa experience na yan, it will not be significant. However, bababa yung AIC kasi ang AIC magiging 2638 compared to 2638.
39 kung hindi kasama kung remove natin si experience. Right? And then the other one, guys, yung backward na using AIC. No? So I want you to run that. Okay, ito pareho lang to, no? Sige, run ko muna. Kasi run ko to. So ano nangyari dito? Sinummarize siya, no? Full model, lahat kasama. Remove race, 2638 yung AIC. Remove number of dependents, 2638.6 na lang. So wala na siya rin-remove, guys. Hindi na niya rin-remove yung pangatlo sa ating yung sa experience. No? Dalawa lang yung rin-remove niya. That's your backward elimination. Okay, so pag i-plot natin to, plot natin, guys. Okay, ano nangyari dito? Full model. Ito yung AIC niya. When race was removed, ito yung naging AIC niya. No? And then when number of dependents was removed, it produced the lowest AIC. Pag tanggalin pa natin si experience, tataas yung AIC. Okay? Yun ang basis natin kasi yung yung AIC in order to remove or not remove a variable. Okay, when you run this, guys, itong details is equal to true ng backward natin. Okay, can you kindly run that? Isa-summarize ulit sa atin. Ito. Details is equal to true. So step by step yan. Tinanggal si race. Okay? So may mga insignificant, no? And then tinanggal si number of dependents. So dito si single, si experience, hindi si significant, no? So pag AIC, guys, titigil na dyan. Backward, no? And then tinanggal si experience. So what happened? Ano ba to? P value ba to? P method. Ito pala yung sa sorry, saan siya? Ito. Okay, AIC. Okay, so quickly lang, guys, kasi you know already what to expect here. Tinanggal si number of dependents. Tinanggal si race. Okay, so wala na. No more variables removed. Dalawa lang. Race at saka number of dependents. Kasi nga ang basis niya, talagang pababain yung AIC. Although sabi nga natin, guys, si experience insignificant. Insignificant siya. Okay, so ano naman to, guys? Ito naman, guys, is ito yung mix, no? Pwedeng forward at saka yung backward. Pero ito usually ang ginagawa niya muna, nag-aano siya muna, nagfo-forward. And then pwede siya magtanggal later on. And it turns out dito sa both fit na to na method, pinapasok natin yung P entering at saka P removing. Kasi dito, guys, sa mixed method, both forward and step and backward, pwedeng magpasok tapos tatanggalin ulit yun. Okay? Pwede siyang magpasok tapos pwedeng tanggalin ulit. Sa kasi sa forward, pag pinasok na natin yan, hindi na pwedeng tanggalin. Sa backward naman, pag tinanggal na natin yan, hindi na pwedeng ipasok ulit. Dito sa mixed, pwede natin ipapasok yon, tapos later on pwedeng tatanggalin ulit. So that's the difference. But usually, guys, Dito, ang lumabas, pareho lang dun sa ano, no? Ang nangyari dito, parang ano lang siya, forward stepwise regression. Kasi lahat inad niya. Wala na siya nakita na parang nag-experiment siya. Pag ipasok ko to, tapos tatanggalin ko naman to. Okay, wala siya nakitang ganun possible na solution. Okay, guys? Clear yun, guys? Clear yung ano, yung clear ba yung both? Yung 1 point, ano natin to? Saan tayo? Tapos na tayo sa 1 point. Sorry, nalito. Model is this. Backward using p-value at saka backward using AIC, tapos na tayo. Tapos yung both, no? Tapos na rin tayo, no? Ito, stepwise. Okay, using both may entering at saka removing. And then dito sa both then, pero using AIC model. Okay? So, kindly run that, guys. Tingnan nyo yung difference. So, yun ang mix, no? Both forward at backward. Okay, now let me, ito guys, itong, okay, tinat ba natin ito? Let's see. Hindi ko rin kasi ano. I didn't run this one. If I run this, okay, tingnan nyo guys. No? Ganun din lahat, addition siya. Walang ano, wala siya nakitang addition, subtraction. May mga cases na magdadagdag siya, tapos tatanggalin niya later on yun. So ganun yung mixed guys, yung forward and backward. Dito wala siya nakitang possible na solution na gano'n. Okay, so ito pareho lang po kanina, yung plot. Okay. AIC both directions. Parang forward lang siya, no? Pinasok itong mga variables na to. Okay, any questions guys dun sa both? Paki-chat naman kung clear. Summarize ko lang guys. Forward, backward. Forward, dalawang methods. P-value at saka AIC. Backward, ganun din. P-value at saka AIC. Meron din yung mixed. Okay? Yung both using P-value and mix then using AIC. Good. All right. So dito guys, sa last dito, intermediate steps. Okay, I'll not run this anymore. Ito guys, ito yung pinaka-importante. Hindi naman pinaka-importante, but this is important. So may function si OLSRR, OLS step all possible. All possible. Ano ibig sabihin nun? Di ba guys, di ba class, meron tayong, we have your RUH as your dependent variable. And then we have yung other, yung mga independent variables natin dito. So, you can compute ilang possible combinations ng predictors. Example, education lang, or experience lang, or race lang, or gender lang. So pwedeng isa lang, no? Or pwedeng dalawa. So pwedeng education and experience, education and gender, education and race, education and civil status. Okay, so there can be different combinations of your predictors. No? So ito, spell out sa atin to lahat. So ang dami nito. Okay. Ang dami nito guys. Alright, so here, we're creating an object called model compare. Model compare natin ang function OLS step all possible. Okay, so let's run this. Print natin si mod compare. So it will take a little time kasi mahaba-haba yan. Okay. Yan.
Yan guys. So print out na niya lahat ng mga possible na. Ilan yung possible combinations? 127. Okay? 100, 7 times 6, 420. So may formula to, ano? You can compute guys for the possible number of combinations ng regressors. Okay, let's take a look at this. No? Okay, number 1 guys. N is equal to 1, ibig sabihin ito, isang predictor lang. So only one predictor. Okay, diba? Itong mga 1, ibig sabihin, isang predictor lang yan. Education lang, tenure, etc. etc. So you're given here your adjusted R-squared. Turns out that's education yung pinakamaganda. No? Okay, dito. 0.16. The rest are very slow. Isa pa nga negative. Okay, pag dalawa naman guys, ito. Education tenure, education gender. Combination guys, combination. Okay, you can see guys that pag 3 naman, combination ng tatlong variables. So lahat ng possible combinations ilalagay niyo dito. And there are 127 possible combinations. Ito yung iisa lang yung 7, ano? So ito naman yung 6, okay, 5, etc. Binigay na measure sa atin yung okay, yung combination ng predictors, R-squared, adjusted R-squared, and your Mallows CP. All right, then let's, if we want to know which is the best one, okay, iran natin isang code dito. Okay, so dito pwede natin i-create yung mod compare as a data frame. Okay, so naka-data frame na siya. So object na to, no? Yan. So sinabi sa atin yung mga different predictors. 127 din lahat to. Hindi nyo na na-print lahat. Okay, and then we can plot. Take a look at this, guys. Plot natin yung object natin, which is mod compare, comparing all the, Okay, so you have here several parameters, no? Schwartz Bayesian information criterion. So iba-ibang ano to, parang akaiki lang yan. So let's take a look at this one. In terms of R-squared naman, in terms of adjusted R-squared, in terms of CP, in terms of AIC. And then dito. Okay. So let's interpret this. Ano ibig sabihin nito? Based on AIC, guys, based on AIC, if you're going only to use one variable, one predictor, si number 1 yung pinakamaganda, yung naka-rectangle, yung triangle yan. If you have 2 variables, si number 8 yung pinakamaganda. Saan yung number 8 na yan? Diba dito? So si number 1, education. Kung isang predictor lang, si number 1 yung pinakamaganda. Pag dalawang predictors, guys, si number 8 daw. Ito yung index yan. This is the index. Education and tenure. If you're going to compare that with the other, models with 2 variables, okay, based on AIC, pinakamaganda si 8. Si model number 3 naman, sa 3 predictors, si model 29, and so on and so forth. Sa number, sa 7 variables, 127, isa lang kasi yan. Okay, so that's what this gives us. Adjusted R-squared, 1, 8, 29, 64, 99, 120, okay, 127. So si adjusted R-squared in this case, at saka si AIC pareho. Okay, questions guys? So far clear? Clear ba yun? Chat naman please kung clear. Among the three steps, which would result the best combination of predictors? Alistair, paki-ano yung question mo? Paki-share with everybody. Okay, anong sagot dito guys? Question ni Alistair. Among the three steps, which would result the best combination of predictors? Anong answer doon? Are you referring, Alistair, to the forward, backward, and both? Alistair? Yung ba
Yes,
referring?
yes, sir. Yes, sir.
Okay, pag ganun kasi, depend. Well, nakita natin, di ba? Si AIC method, iba yung ano niya dun sa sa P method, di ba? Magkaiba yung output nila. Okay? So pag may ganyang conflict, guys, always stick to the P value. Kasi yun ang standard na na acceptable na parameters eh. I can't imagine you, kunyari sa paper nyo, ang ginamit nyo na basis is the AIC. Tapos yung isang doon, yung isang variable doon, ang p-value niya is, kunyari, parang 0.12. Tatanungin ko yan, bakit yun ang ginamit nyo na basis? Bakit hindi na yung standard na p-value? Oftentimes naman guys, pareho sila. Walang conflict. There are instances lang na magkaiba sila. Did that answer your question, Alistair?
Yes, sir. Thank you.
Thank you.
All right. Possible ba, sabi ni sabi ko nabasa, Ziska, na iba yung plot sa amin? Ziska, what plot are you referring to? Anong plot?
Sir, mine is like parang line graph siya.
Saan? Sa? Anong
Then
Anong-
sa ginawa sa mod compare po.
mod compare? Here, dito?
Yes, sir.
Tingnan natin, hindi ko ma-visualize siya. Jiska, gawin kitang co-host, pakishare yung ano mo. No? Kindly share your screen. I want to have an idea what you mean.
Okay po.
Sige. Ginawa na kitang co-host, ha?
Sir, can you see it po?
Yeah. Ano? Yeah. Can you see it, class? No? Iba yung diagram ng plot niya. Plot mod compare. Okay. Tapos wala yung ano, no? Okay, I'm not sure. How about you guys? Parang ngayon ko lang nakita yung ganyan ano. Thank you Ziska. How about you guys? Ano yung lumabas na ano nyo? Is it the same as Ziska's or the same as yung ano ko yung plot? Can you please comment, please? Okay, same with my plot. Okay. Yung iba, guys, thank you, Alistair. Thank you, Richmond. So, I don't have the answer right now, Ziska, but I'd like to see, baka, rinan mo ba yung mga previous na, ano? Did you run the previous code chunks?
Apa.
Okay. Subukan mo ulit na i-run, no? Doon sa simula ng, ano, simula ng mod compare, and then try to see again. Okay? Tapos kung wala pa rin, i-chat mo ako para i-discuss natin. I'm not sure why. Kasi dapat ang kakalabas ng dapat makikita natin kung ano yung pinakamagandang model based on a particular criteria like SBC, Schwartz Bayesian criterion, okay? Tapos or R squared or AIC, tapos naka-indicate doon yung kung ano yung model na pinakamaganda based on kung ilan yung predictors na gusto mong gamitin. Okay? Alright, so ito naman, the all possible model gives us all possible regressions. Let's see. Subset to. Okay. Thank you, Ziska. Thank you for that question. So ito naman, baka iba yung na-plot mo na, Ziska, baka ito ng sandali, let me see this. Kasi mod compare, and then binago ko na dito yung OLS step best subset. Best subset na to. Okay. So ito guys, sinubset na niya, no? Okay, dito sa, I don't know kung pareho tayo ng row number, dito sa row number 518, ang ginagamit kong function dito, best subset. So this tells us guys na pag model number 1, which is one predictor, education lang yung predictor. No? Kung dalawa, ito. So yung yung best subsets no? I think you were running this one. So ito. Yan. Ito 'yon, no? I think you were running this one. Yung nasa dulo na, no? Ziska, that's the answer, no? Ito rin ang kanina. Yung last na plot mod compare, siguro dapat ang ginawa ko dito, dapat siguro mas maganda kung mod compare 1 ako dito. Kasi yung mod compare ko dito, okay, all possible to no? Yung unang mod compare natin, all possible. Siguro mas maganda kung mod compare ko dito, nilagyan ko ng 1 para mod compare 1. So it will be different from yung all possible kaysa dun sa sa best subset. Okay? So Ziska, I think that answers your question. Okay. Thank you.
Thank you, sir.
Okay, yeah. Yeah, as Alistair pointed out here, kapag best subset, yeah. Kasi ang best subset, guys, ang pinapakita niya ngayon, no, kung 1 lang, so ang measure ng R squared na, ito lang, no? Pag dalawa, 0.3 something. So you notice, guys, sa R squared, while if you keep on increasing your predictors, tumataas talaga siya ng tumataas. Okay, so dito naman sa adjusted, tumataas siya until such point na pag nagdagdag ka pa ng na hindi na significant, tingnan mo, bumaba na siya. Ito, yung 7, bumaba na yung adjusted R squared mo. So no use, guys, no use adding more predictors kung hindi naman sila makakatulong dun sa pag-explain ng variable natin, ng dependent variable. Tapos AIC, bumababa din, guys. Okay? But it reaches a certain point when, if you keep on adding, guys, tataas na yung AIC mo. Okay. Alright, so may references lang dito. Okay, so next meeting, guys, okay, hindi na tayo makakapagsimula ng pumunta tayo sa diagnostics, guys. Ang titingnan natin yung mga error terms natin. And then we will also go into we will have examples of yung mga factors natin. Okay, and then more examples of interaction of the variables. Pag sinabi interaction, i-multiply natin kunyari pwede ba i-multiply si education at saka si gender? That's what we call interaction. Pwede nating pwede bang gawing regressor 'yon? Multiply natin si experience multiplied by race? Yes, that's possible. That's what we call interaction. Okay? So what else? Any questions, guys? Any questions? Just in time lang tayo. Natapos natin yung stepwise regression. That's what we intended to discuss with you today. Any questions? Any comments?
Clear so far, guys? Paki-chat nga kung clear so far. Of course, guys, it's best for you to review this. No? Nasa inyo na naman yung code. Binigay ko na sa inyo yan. So, tingnan nyo kung ano nangyayari. No? Try to see what's happening when you run your codes para as you gain familiarity, guys, you'll develop more mastery with the LM function, tsaka OLSR. Okay, paki-chat nga please kung clear so far, guys. Thank you. How about the rest? Okay, thank you. Okay. Ito, konti lang nag-chat, nag-ano. Yan, salamat. Okay, with that, guys, I'll stop recording.